after we've learned how to deal with our moments in mechanics, obviously not in life, we learn how to going to be using force to solve problem in world. Force and friction. Of course, we're not going through violence. It's not allowed, you know. Right. Anyway, I'm going to combine two chapters together, this chapter 5 and chapter 7, because I feel like chapter 7 is just a continuation of chapter 5. So I think it makes sense to put it together to do chapter 5 and then chapter 7. And then we'll come back to chapter 6 afterwards. So in your tracker sheet, if you have given you a tracker sheet, you'll realize there are only 4 chapters in your tracker sheet instead of 5 in the textbooks, mainly because chapter 5 and 7, I combine them into just one topic, which is called force and friction. Right, so today we'll look at 5.1. Now, chapter 5 is an introduction, I would say, to chapter 7. It's just preparing you for chapter 7, really. So is there anything that you need to learn in chapter 5? Of course there is, because it contains all the basics, including force diagram, how to draw the forces, how to resolve forces, etc. And then you're going to carry on these knowledge into chapter 7 exam questions. All right, so let's dive in 5.1. So resolving forces. Now, last year in year 12, you would have learned how to find the magnitude of a force in a vector form. For example, if you're given F equals 3I plus 4J Newton, you want to find the magnitude of F. So if you don't know this, this modular sign means the magnitude of F. We know the magnitude of F is the I component squared, so 3 squared plus, and then plus the J component squared, square root, do Pythagoras, make him proud. So 3, 4, and 5. So the magnitude of F is 5 Newton. Okay, and you can also learn to work with the angle that makes the I directions. If I draw an axis very quickly, you've got I, well, it should be I and J. Okay, if I'm doing 3I plus 4J, I'm doing 3 on the right and 4 up. So let me use a different color. So 3I. So 3I in here. So that's 3. And then 4J. So 4J in here. So that's 4. Essentially, the force, this is the magnitude of F. Right? So that's F. Now, F, we want to work out this angle here with the horizontal I direction. So to do the calculation, we can do, if I bring the 4 over, I can do 10 theta equals 4 over 3. So if you do inverse 10 of 4 over 3, you will get 53.1 degrees. So that's the angle it makes with the I direction. Now, when it comes to reversing this process, that is, let's say if I give you 5 Newton and a 53.1 degree, and then I'll ask you to work backwards to work on the I and J component. So instead of using 3I plus 4J, I'm going to give you these component, and you're going to bring it back to 3I plus 4J to me. This is the process known as resolving the force. And essentially, that is the lesson we're going to learn today. All right. So let's have a look. Example. Let me change the color for the highlighter first. I don't like orange. Example. Resolve the following force in the X direction, in the Y direction, and hence write, obviously that means the typo, the force in Xi plus Yj form. So first of all, what we're going to do is, if we're going to resolve the force in X direction, we can make a right angle triangle that connects with the X-axis. So to do that, part A, what I can do is I can make a right angle triangle here with the X-axis. Right? And there's 7 Newton. Now this angle here would have been 65 degrees. And then that's my X value. So that's my X. Okay, so that's my X value. Right. Also notice direction of the X is going left, because in order for 7 Newton to be going downwards on the left-hand side, like a southwest direction, if I'm right, southwest, I'm not very good at northeast, southwest. Yeah, southwest direction, bottom left, X must be going to left, okay, must be going to west direction. So in here, if you set the triangle correctly, your 7 Newton will always be in the hypotenuse, because like the previous one, the 5 Newton should be in hypotenuse. All right, so the force, the magnitude will be on the hypotenuse. So this will be cos 65 degree equals X over 7. So multiply 7 over 7 cos 65 degree, which for the calculator is 2.96 Newton. Let's do the same for Y, similar to Y, but this time for Y, I am going to make a connection with the Y axis. Oh, this is a triangle I'm going to make. and that was 25 degree in here, and that's a 7. Now for the y, we're going bottom, because to make an overall force going to bottom left in the southwest direction, the x value must be going west and the y must be going south. So using trigonometry again, this time cos, same as cos 25 degree equals y over 7. So y equals 7 cos 25. Put that in the calculator, that will give you 6.34 Newton. So that's the answer for part A and part B. Part C. Hence, write the force in xi plus yj. So the x value is 2.96, but because we're going to the left, so it will be negative 2.96i, and then going down will be negative again, negative 6.34j, and that will be the Newton. That's how we can write 7 Newton as it is. To double check your answer, we can do the Pythagoras. So square root of 2.96 squared plus 6.34 squared. If you put that in calculator, let me double check. Just in case, I make a lot of silly mistake as well. Square root. Yes, I got 6.999 something, should roughly equal 7, so I know that's correct. Okay, that's how we are going to rewrite the process, reverse the process. So this process, the whole thing that we've done in here, from 7 Newton to negative 2.96i minus 6.34j is called resolving the force. Okay, right, so let's have a go, a bit of notes. So notes, any resultant force that is diagonal, like the F in here, or the 7 Newton we've seen in the previous example, it could be resolved in 2 directions. Not x and y, they're called, so the proper name is a direction. Oops, sorry, this direction parallel to the movement, or so basically this is called the x direction. We usually call it x direction, so we can call it x and y. For now we'll call it x and y, but the proper name is direction parallel to the movement, also direction perpendicular to the movement, also known as the y direction. So from now on, remember, so we can resolve into 2 bits, 2 directions, x and y. If there are more than one forces acting on the body, then what we have to do is then first we're going to resolve. You can see that's I, means first we have to resolve the forces into x and y direction. So like similar to previous EG, similar to previous EG. So that EG we've done in page 3 in here, this example. Or, and 2, second step, we're going to find the sum of forces, also known as the resultant forces, resultant force in each x and y direction. I'll explain a bit more in the next example, okay, in each of the x and y direction. So let's have a look how we can do that in an example. Example, find the sum of forces. Now, if you remember the word resultant, you've seen this word in moments. Resultant means the verdict. For example, remember that example I made about some year 7, year 8 pushing a door. This one making anti-clockwise moments and this one making clockwise moments. The resultant moment is which side wins. So if the clockwise moment wins, then the resultant moment will be a positive something clockwise, something, positive Newton meter clockwise. If the anti-clockwise is bigger, obviously then overall the door will be moving in anti-clockwise direction, and the sum of moment or resultant moment will be positive something but anti-clockwise. So same in here, sum of forces. Imagine you in here quite unhappy because you've got a dilemma to face in here. One side, your baby sister, okay, sorry, my internet just broke, so I don't know, just disconnected. I don't know where I was finishing. Anyway, so I was saying, imagine that's you. Okay, so here's you, quite unhappy because you've got a baby sister. Okay, on one side, trying to say, brother, can we play some toys together? Let's go to the park with me. Okay, so pulling you that side. And on the other hand, you got your mom with a face that she's going to ask you to do something. Okay, so the mom. Okay. Mom said, okay, son, can you go to the supermarket and fetch me some eggs or something? Let's go. Okay, so come with me, go to the supermarket. Right. So obviously, mom is a developed, a grown woman. Obviously, she can pull harder, even though if it means taking you out the limbs, and she will still manage to grab you to the supermarket with her. On the other hand, your sister, too small, too young, you can pull out her limbs instead. I'm not just kidding, don't do that. We'll talk about forces today, violence. No violence, I said. Right, so mom is exerting 10 newtons to right, and your baby sister is only managed to exert 3 newtons to left. So what is the resultant force in here? The resultant force in the horizontal level in the x direction would be, so the resultant will be 7 newton, because to right, because mom 10 minus 3 is 7. Now, same thing in here. What about up and down? Now, up and down, remember, we're all sitting on the ground. Sorry, I didn't draw them on level. You know, you hope you get it. But the sister is, you know, sister's leg is underground, whatever. She's a superwoman, crazy woman. Right. So what about upwards and downwards? Now, the resultant will be 0 because you're not floating or you're not sinking. The weight that you give to the ground will be same as the reaction. So in terms of upwards and downwards, the resultant will be 0 because reaction equals weight. Okay, so that's the concept we're talking about in here. Now, that's easy to understand because they're all either vertical or horizontal. Now, the problem here is what happens if the force is diagonal? Now, the force is diagonal, we can't compare quite easily. So what we can do is we're going to convert them, known as resolving them, into just the x and the y direction. So we can compare in terms of x and in terms of y. All right, so let's do it one by one. So what we need to do is we need to resolve the force on each direction. So let's do 2 newton first. So we need to resolve, remember the previous page, what we need to do is first we resolve the forces in the x and y direction. So when you first resolve the 2 newton, that's the first step. So I'm going to draw 2 newton out again, 2 newton, and then this time I can make a right angle triangle like this. Now in terms of x and y, because the 2 newton is going top left, as in northwest, so the x must be left and y must be upwards. Okay, so the angle is 45 degrees. So in terms of x, if I use trigonometry on x, just on x, ignore y, I could do cos 45 degree equal x over 2. So x equals 2 cos 45. Plug that in a calculator, 2 cos 45 is root 2. So x equals root 2 newton. Now, same with y. This time y sine 45 degree equals y over 2. So multiply over. So y equals 2 sine 45, which is also root 2 newton. So what it means is, instead of having a 2 newton, we have a root 2 on x and root 2 on y. Now, we'll come back to this in a bit. Let's do the same for the 4 newton. Let me change the different color. So let's do 4 newton. Okay, so the 4 newton, I can again make a right angle triangle in here. So resolve 4 newton. In order to find the sum of forces, I need to first resolve each of them so we can compare. Remember, I need horizontal forces and vertical forces. Diagonal is not going to help us. So we're going to draw this out. Look at the direction of the 4 newtons pointing top right, 4 newton. So therefore, I know x is going to right and y is going upwards, and that's 60 degree. Trigonometry, I'm going to skip some steps in here. So x equals 4 cos 60. So 4 cos 60 is 2 newton, and y will be 4 sine 60. 4 sine 60 is 2 root 3 newton. Now, next, what can we do is we can then summarize them into one big force diagram. So force diagram with only x and y in there. So we're not using the 2 newton and 4 newton. We're going to use the resolved version of the 2 newton, 4 newton. So what does it look like? Well, first of all, we've got x and y in here. Now, the 2 newton on the 2 newton has been resolved into root 2 on the x and root 2 on the y. So I'm going to put root 2 because root 2 on x is pointing to left. So in here, I'm going to put root 2. And y is pointing upwards, we also have root 2. To color code it for you, the 2 root 2 highlighted is gone here. Next, we also have the 4 newton that's been resolved. So let me choose different color. Let me choose the the blue color. So in here, x is going to right, by 2 Newton and y is going up by 2 root 3. So we're going to put this into the force diagram. So x going to right is 2 Newton and y going upwards is 2 root 3. So these two have gone now here. Now, what about the original 2 Newton and 4 Newton? They're gone because they've been resolved. Okay, it's like putting a vitamin tablets. I don't know if you have some those tablets like vitamin C that, and then it fizzles into the water, and then it actually tastes quite good. The vitamin C ones, like orange juice. But the same thing we're doing here. Resolved. So resolved, like dissolved, it's gone. 2 Newton, 4 Newton is gone. So it's gone into root 2 on the left and root 2 upwards. And for 4 Newton, it's gone to 2 on the right and 2 root 3 upwards. Now, once we've got this diagram, it's much easier to do our conclusion, our verdict. How? Well, so therefore, next step, we can do our sum of forces. The next sum of forces. Now, you can only compare x with x and then y with y separately. So you can't do x and y together. Okay, so sum of forces on the x one, the final winner is so 2 on the right and 2 root 2 on the left. So sum of force in x direction will be 2 minus root 2 Newton, which is 0.586 Newton. And for the y, because they're both going upwards, so root 2 plus 2 root 3 Newton, because they're going up, both going upwards, so it'll be 4.88 Newton. So that's the answer you need, okay? Now, but I'll also explain what it means in context of a question. What it means is in context is the ultimate winner. So let's say we've got x and y in here again. We're going to the right by 0.586 Newton and going upwards by 4.88 Newton. So that's the resultant force. This is the overall resultant. So in other words, after the 2 Newton pulling you left in an angle 45 degree and 4 Newton pulling you to right by 6 degree, overall, your overall resultant force is going to top right by 0.586 Newton to x and 488 to the y. All right, so that's the overall resultant. So, okay, right. We're going to look at one question with a example in there. So a box of mass 8 kilogram lies on the smooth horizontal floor. A force of 10 newtons applied to the angle of 30 degree, causing the box to accelerate horizontally on the floor. Work out the acceleration of the box. Right. So what do we have in here? Well, first, we know the box is going to move horizontally. That means the box is going that way. Okay, a meter per second squared. We don't know how quick. But with a box, as you know, we have to put all the forces in there. So we know the box will accelerate 8 Newton to the ground. And we also have reaction upwards. There's no friction. So normally on the box on the floor, you only have the weight and the reaction. All right. So what we can do is we can imagine there is a axis in here. So imagine there's an invisible axis. Oh, I mean to use blue. Imagine there's an invisible axis in here, using the center of the box as the origin. Right. Now what you can see in here is the 10 Newton is basically diagonal. So I'm going to write your notes in here. Okay, so use different color because it's no. We need to actually, when you resolve, first step, when you resolve 10 Newton, why do we need to resolve it? The reason being is 10 Newton is diagonal. Right? So when we resolve 10 Newton, do you remember how we resolve 10 Newton? We could draw a right angle triangle in here, like that. 10 Newton to the top left, top right, x to the right, and y upwards. We've got 30 degree in there. So using trigonometry, x equals 10 cos 30 degree. So use 10 times cos 30, you get 5 root 3. And then for the y, it will be 10 sine 30. 10 sine 30 is 5 Newton. So that's the first step, resolve. Second step, what did we do last time? We do a force diagram. So force diagram. So force diagram means we only put the forces on the x and y axes. Now, if you get confused today, don't worry, because we're going to continue with these type of working out throughout the whole chapter 5 and chapter 7. It's like moments as their own working out, where we first of all make upward force equal downward force, take moment at a point, and then clockwise moments equals anti-clockwise moments. But in forces, we're going to resolve the force. Second step, draw the force diagram. Okay, so draw a force diagram. We've got the reaction on top and we've got Ag at the bottom. Next, the 10 Newton has been resolved into the 5√3 to the right and 5 Newton upwards. So let me color code it for you. So we've got in here, let me just color so green. So this 5√3 and the 5 Newton, I'm in blue. 5√3 and 5 Newton is now 5√3 to right and 5 Newton to right, to upwards. Now, it's quite important that you must know the direction of the forces, okay? Because if you put in the wrong direction, it's that resultant force. If you put in the wrong place, you get everything wrong. Right. So next, to work out 5/5, what we'll do first of all is acceleration of the box. So that step. So I'm mumbling. Right, let's try again. To work third step, okay, acceleration. Now, if we look at just vertically, okay, on the y direction, there's no acceleration, right? So if there's no acceleration, then surely the upward force R plus 5 will have to equals 8g. So R equals 8g minus 5 equals 8 times 9.8 minus 5. That's 73.4 Newton. And that's the reaction. Actually, that's the answer for part B. Now, in mechanics, you can answer any question in any order. And then, now, what about horizontally? Now, horizontally, because there is a acceleration, you've only learned one formula about force and acceleration, which is known as the F equals ma. Now, what's the force? The force in here is the resultant force. So on the x-axis, we look at the x-axis, there's only one force pulling it forward. The reason that it's accelerating because of this force 5√3. So 5√3 equals the mass 8 times a. So a equals 5√3 divided by 8. And that's going to be 1.08 meter per second squared. So I bet you must be quite confused what to do in the sorry about the bell. About the question. So I'm going to show you exercise 5A, question 3A. Okay, exercise 5A, question 3A. So I'm going to show you one more question how to do that. So first of all, you're going to draw your own axes in there using the particle as the center of the origin, so x and y. Next, you're going to resolve each force. Okay, so you're going to resolve 25 Newton. Now I'm going to let you pause the video and have a go how to resolve 25 Newton. The final answer should have x equal and y equal. Draw a triangle out. And for the 25 Newton. And do the same for the 35 Newton. Reason we have to resolve them is because they're diagonal. So in a 35 Newton, that's what it should look like. 35 Newton, 30 degrees. I'll let you decide. And then you've got x equal and y equal. Once you finish that, you should be putting it into a force diagram that with the x and y value you've got in here, with the right direction, of course. And then the third step will be finding sum of moments on the x direction and the y direction. Okay, so you should pause the video now, have a go with the question. So this is the answer for the 5A question 3A. You've got the resolve the forces and they put in a force diagram. Once you've done that, you then put in the resultant force, you've got the x and y. But the question also asks you for the magnitude. So to find the magnitude, what you have to do is just with the particle, what we know is, we know 19.2 to the right and 36.7 upwards. So then that's the resultant force. So the magnitude of the resultant force will be the square root of Pythagoras over 2. Let me just put the calculator. And that will be 41.4 Newton. And they also ask you about direction. So that's the theta. They're asking for the theta will be inverse 10 of 36.7 over 19.2, which would be 62.4 degrees, 62.4 degree. So direction would be 62.4 degree above the horizontal to the right. Okay, you might encounter a question that the left force is bigger than the right, and everything will be the same, but it's just that over direction will be pointing to the left instead. So that's 5.1.